All right, so in this video, I'm going to introduce the topic of exponential growth and decay. And this is something that is all around us all the time. There's lots of examples for exponential growth and decay, but basically, what it means for something to grow exponentially is for something to grow increasingly quicker, right? So, not like a steady growth, like linear. We've looked a lot with linear in the algebra class. Now we're talking exponential. So I'm just going to read this green box here. There's many things in the real world that grow faster as they grow larger or decrease slower as they get smaller. These types of phenomena, loosely speaking, are known as exponential growth and decay in the case of decreasing. In today's lesson, we'll look at both growth and decay. So let's just brainstorm quickly. I give one example here, and I'll talk about it in a second, of something that can be considered growing exponentially. I want you to come up with 3 other ideas that you can think of where something grows exponentially or decays, right? Decreases. So my example is a zombie apocalypse. So if you think about it, let's say we got one zombie, right? So this is don't judge my zombie, okay? This is my zombie. And these are 2 unsuspecting people just living their life, right? And then the zombie bites these 2 people, right? And then all of a sudden the next day, those 2 people bite 2 more people each. And then the next day, the 2 people that those 2 people bite each bite 2 more people. And you can see how it starts with one zombie and it gets really out of control really quickly. So a zombie apocalypse or a zombie infection is one example of exponential growth, right? Because it starts small and it increases really quickly. I want you to come up with 3 other examples, and please use full sentences that are examples of either exponential growth or exponential decay. So let's go through an example. This example says the number of people who have heard a rumor often grows exponentially. Consider a rumor that starts with 3 people and where the number of people who have heard it doubles each day that it spreads. So think of this person, right, this original person as the one that knows the rumor. And then this person tells 2 people, right? And then the next person again tells 2 other people. So just keep thinking of visualizing the patterns here. So why does it make sense that the number of people who have heard a rumor would grow exponentially? Okay, I want you to answer that in a full sentence in your own words. So pause the video and answer part A. Part B says, fill in the table below for the number of people N who knew the rumor after it had spread after a certain number of days D. So in column D, this is days. And this is the number of people. Excuse my awful handwriting on this board. Number of people who know the rumor. So on day 0, 3 people know. And then each day, it's going to double. So double of 3 is 6. What is double of 6? Well, that's going to be 12. What is double of 12? 24. It's getting pretty big pretty quickly here. Okay, and then keep doubling that. What am I doing when I'm doubling? I am multiplying by 2. That's what doubling is, times 2, times 2. So I want you to copy this table into your paper or loose leaf or wherever you're copying your notes and finish the rest of the table, okay? If you have to use your calculator, that's fine, but keep doubling for days 4 and 5 and get your answer. So we would like to determine the number of people who know the rumor after 20 days. Now, we don't want to have to just write out each day in a table like that, because what if I asked you to find out how many people know the rumor after 100 days? You don't want to have to write out 100 instances of this situation. So it's good to develop some sort of formula or some sort of pattern. So let's start doing that. So on day 0, we're right here. the number of people that know the rumor is 3. And then on day 1, we take 3 and we double it, right? We times 2. The next day, day 2, we take the day before, right? So that's what's here, the day before, and we double it again. So what that really looks like is 3 times 2 times 2. Then we're going to take the day before, right? So 3 times 2 times 2, and again, we're going to double that. So are you starting to see a pattern here, right? So really that's 3 times, how many 2's are there? 1, 2, 3. 3 times 2 to the third power. And then again on this day, if there was, all right, let me clear up all of my messy notation here and try to come up with a pattern. There was no 2's here. There was 1 2 here. There was 2 2's here. There was 3 2's here. So how many 2's, how many times are we doubling by the fourth day? That's going to be 3 times 2 to the fourth power is how many people know the rumor. And then 3 times 2 to the fifth power. Are we seeing a pattern yet? So we have our starting value and we keep doubling each day. So times 2 to whatever amount of days we're on. So for part B, it wants us to use the pattern we developed and write a formula for the number of people that know the rumor. So the number of people that know the rumor is equal to 3 times 2 to the D power, because whatever day we're on got filled into that exponent. So how many people would know the rumor after 20 days? Well, 3 times 2 to the 20th power will give us that answer. So I'm going to take out my handy dandy calculator. And I'm going to type 3 times 2 to the 20th power. That is a lot of people. How do we even read that number? Do we remember? Well, remember, starting from the right, each third number you put a comma. So this is 3 million people, 3,145,728 people know the rumor. So you can see how we started out with 3 people, and after 20 days, that's how many people knew. This is how exponential functions work, okay? Exponential functions are basically functions that have the variable in the exponent, right? Because you're multiplying. We don't have a constant rate of increase. We multiply to increase. Okay, so there is a bonus question. It's optional. You can try that for some extra credit. And then this exercise down here is just asking you to find a pattern based on the situation. So I do want you to do this one on your own. This one is not optional. This one you have to try to figure out the pattern on your own.